Hey guys, this is Mr. Lowry. This is an in-class assignment that we did on 11/16. It's a Monday if you're in Cohort A. If you're in Cohort B, this will be done on 11/17, which is a Tuesday. We're going to start here by looking at this graph and trying to kind of interpret different things from this graph. Our goal here today is to talk about key features of a function, or key features of the graph of a function. Okay, so right now we're talking about the height of a diver's head t seconds after jumping off a cliff. Now the reason why we're talking about just the diver's head is because if you think about where you're measuring from on a body is anywhere from 4 to 6 feet. So depending on where you're measuring from, you could potentially have a different height. If a diver is standing on a cliff, for example, and the cliff is 20 feet high and he's 5 feet tall, then his head is going to be 25 feet above there. So this is just kind of where we're measuring from. What you should do here on this activity is you should pause the video here if you haven't done this already, and you should see if you can answer these questions on your own. I think you could probably come up with quite a few of them. Some of them use function notation, but most of them are just talking about interpreting this graph. We're going to unpack these ideas in a minute and use them to help us with our homework, but for now we just kind of want to see if we can interpret the graph. So go ahead and pause this, print it out, and then do as much as you can. Okay, so we are coming back from you pausing this, and hopefully you've worked through a lot of this on your own. Let's take a look at some of these and see if we can figure them out. Okay, so the first one says find the x-intercepts of the graph. Okay, x-intercepts are where the graph crosses the x-axis. So here's the x-axis, here's the y-axis. Now in this function we're actually talking about height and time here. So this is maybe more of like these all represent time, so maybe we should use t for this and h for this, but you get the idea. So we're looking for where the graph crosses this axis here, and it looks like it does that here and here. So if this is 1 and this is 2, this to me looks like it's about 1.5, and this is 2 and this is 3, and this is right about 2.5. So our x-intercepts are going to be at 1.5, 0. So 1.5, 0. Remember, this is a coordinate. It's 1.5 seconds, but 0 in height. And then our other one is 2.5 seconds, 0 height. Okay. In the context of this problem here, we're maybe thinking that this is the water. So this diver is jumping off the cliff. Looks like he's going below the water and coming back up. So these are the times where the diver is basically crossing the surface of the water at 1.5 seconds and 0 seconds. So we could put the diver goes below water level at 1.5 seconds and comes back out at 2.5 seconds. So a little cramped there, sorry about that. Put that in your own words, but that's kind of the idea, right? Those are the x-intercepts. Okay, now here's the y-intercept where the graph crosses the y-axis. This would be the y-axis, or in this case it's really more the h-axis, the height axis. But this coordinate right here would be 0, 24. Okay, so this the diver is 24 feet above the water at 0 time. And we're talking about his head, so his head is 24 feet above the water. So we'll say diver is 24 feet above the water at 0 seconds. We have to measure from somewhere, so that's why we're going to measure from his head. Okay, during what times is the height of the diver increasing? Well, there's a couple. So notice that he jumps up, and then he falls down, goes under the water, and then he comes up out of the water. So if we divide our domain here, it looks like there's some sections where he's increasing. So from here to here, his height is increasing, right? And from here to here, his height is increasing. Or sorry, from here to here, his height is increasing. So from for what times? So 0 to, so this is 1, this is about a half right here. This would be 0.25. 0 to 0.25 seconds, and 2 to 2.5 seconds. All right, so from here to here, he's increasing, and from here to here. Okay, during what times is the height of the diver decreasing? So that's like from here all the way down to here. So he starts decreasing right about 0.25 seconds. And he keeps going down, 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 down until he gets way down here, and that's about 2 seconds. And then during what times is the height of the diver constant? So right here, his height is constant. So this might be his head pops out of the water a little bit, and he's swimming back to shore, but his head is kind of the same height, just a little bit above the water. So from about, say, 2.5 seconds to 5 seconds. We don't know what happens after 5 seconds. Maybe he gets out of the water or whatever, but that's where it stops. Okay. During what times is the diver above the water? Okay, well, in this case, the x-axis here kind of represents the height of the water, right? So from here to here, he's above the water. So from 0 to about 1.5, and then about 2.5 to 5 seconds. Okay, so I'm going to jump back and forth here, but he's above the water here, goes under the water, and then he's above the water for the rest of the time. Okay, during what time is the diver below the water? Okay, well, he's below in this area, so from 1.5 to 2.5. Okay. What is the diver's maximum height? Okay, so the highest he's ever going to get is up here, right? That looks like it's about 25 feet off the ground. Okay, and then what is the diver's lowest height? So he goes under the water. The lowest he gets is -5. That would be like 5 feet below the water. So the minimum height, the lowest height he's possibly going to be is -5 feet. And in this context, that means 5 feet below the surface. Okay, for the domain, we're looking for all the possible x values. So the lowest x is over here, and the highest x is over here. So we go from 0, the lowest possible x value, 0, to the highest possible x value, which is 5. So in interval notation, we're going to go 0 to 5, and with brackets on either side, so we can include them. Okay, now we already kind of got a lot of the range here because we knew our lowest height was -5 and our highest height was 25. So the range is all the y values. The lowest possible y value, or I guess in this case height, the lowest possible height would be -5, and the highest possible height would be 25. So our graph lives in between -5 and 25. And we're going to put some brackets there. Okay, the next questions are just function notation. So find h of 1 and interpret it in the context. So in this case, height is a function of time, right? Height depends on time. Time is the independent variable, height is the dependent variable. So h of 1 is telling you, I want the height, but this guy right here is the time. Okay, so what is the height after 1 second is what this is asking for. So here's 1, that's 1 second. How high are we? Looks like we're about 16 feet. Okay, so this point right here is like 1/16. So after 1 second, we're 16 feet. Interpreting that in function notation, h of 1 equals 16. Okay, what that means is the diver is 16 feet high at 1 second, or 1 second after he jumps. His head is going to be 16 feet high. Okay, now this one's kind of the opposite. Find the value of t for which h of t equals -4. So what they're saying is the height is -4. What's the time? This is what we don't know. Height is -4 find that time value. So our t equals is what we're looking for. Okay, so we want to know at what time is the diver negative 4 feet. So here's negative 4. So it looks like there's 2 times when that happens. He's diving in, he gets to negative 4 feet. Right about here, that's going to be, this is 1, this is 2. So this is 1.25, 1.5, 1.75, 2, 2.25. So at 1.75 and at 2.25, he's at 4 feet. So there's actually 2 times here. 1.75 seconds and 2.25 seconds. Okay, so I think a lot of those questions you could answer on your own just by interpreting the graph. Okay, what we're going to do here is we're going to add a little bit. Okay, this is going to help us with our homework. So up here we're going to do some notes here and just kind of take the information from what we got. The first one we want to talk about when we talk about key features, we talked about x and y intercepts. Okay, we also want to talk about intervals of increase and decrease. Okay, so some of these questions ask you about him going up and down. So during what times is the height of the diver increasing? During what times is the height of the diver decreasing? So we already answered these questions. The difference here is that we need to use interval notation. Okay, so one of the key features of a graph is to describe when it's increasing and when it's decreasing. And in order to do that, we're going to use intervals. Okay, so let's talk about the interval of increase for a second. Okay, now before we had these 2 intervals. We said that the diver was increasing from 0 to 0.25 and then from 2 to 2.5. Okay, so we're just going to take that information and we're going to write it in interval notation. So from 0 to 0.25. Okay, now let's think about this for just a quick sec. He's not really increasing at 0. He's just standing there. He's not really increasing at 0.25 because that's where he starts to turn around and starts going down. So at this peak, he's neither increasing nor decreasing. He's just kind of like neither. But in between, he's increasing. So when I write this interval, I'm going to put parentheses around it. And that makes it look like a coordinate, but it's not. It's an interval. So anywhere between 0 and 0.25 seconds, he's going up, but we're excluding 0 and we're excluding 0.25. But anything in between is good. Okay, now we had another interval. My lights keep turning off. Sorry. We had another interval here for increasing. Same idea. He was also increasing from 2 to 2.5 seconds. So what we're going to do is we're going to write that other interval, 2 to 2.5, okay? And again, we're not going to include those. At 2 seconds, he's not increasing. He's almost increasing, but he's kind of right in the middle. He stops decreasing, and he's about to start increasing, so he's neither increasing nor decreasing at this valley here. Okay, and then he increases all the way up to here, and right at this corner where he stops, he's not really increasing at that spot either. So that's why we're using parentheses. We don't want to include those points. Since we have 2 intervals, we're going to tie them together with this symbol, which is a union symbol. That's how you basically tie 2 different intervals together. Okay, so that's the interval of increase. Okay, let's talk about the interval of decrease. Okay, so again, we kind of already answered this question. We just need to translate it into function notation. Okay, so during what times is the height of the diver decreasing? Well, we said between 0.25 and 2 seconds. So between 0.25 here and 2 seconds, right, he's decreasing. So from here all the way to here. But we're talking about times, right? We don't care about height. We're just talking about the times. So our interval is 0.25 to 2. Sorry, decreasing was to 2 seconds. Just going to go back here and double check because I think I said that wrong. What time is the height of the diver decreasing? From 0.25 to 2 seconds. From here, this time, to this time. So this is what our interval looks like. And again, that looks like a coordinate. It's not a coordinate, it's an interval. And we just know from context that we're talking about intervals of increase and decrease here. So that's an interval. It's saying from time 0.25 all the way to time 2, or from 0.25 seconds to 2 seconds, anywhere in between there, he's decreasing. Right at 2 seconds, he's not decreasing anymore because he's kind of turning around. And right here at 0.25 seconds, he's also not increasing or decreasing. Okay? We also want to talk about intervals where he's positive and negative. So intervals of positive and negative. Okay, now this is easy to get confused with increasing, decreasing, but we're not talking about if he's going up or going down. We're talking about if he's above the water or below the water. Okay, so anytime he's above the water, that's going to be positive. So this is the positive realm. This is the negative realm. So we want to find the interval where he's above the water. That would be positive right here. Okay. So if we go back and we look at above the water, during what times is the diver above the water? From 0 to 1.5, and then from about 2.5 to 5. Okay, so again, back over here, he's above the water from here, from 0 all the way to here, he's above the water. Then he dips below the water for a little bit. Then he's above the water again. So from 0 to 1.5, he's above the water. Then from about 2.5 to 5, he's above the water again. So our intervals look like this. 0 to 1.5, again, we're not going to include either of those because when he touches the water, he's not above or below. Right when he hits the level of the water, he's not above or below. He's just at that level. Same thing over here. Right when he hits this point, he's not above or below, right at that point. So this is where he's above. Now there's another interval because he pops up around 2.5 seconds, and he's above the water until the end of the graph. Okay. Now we're not sure what happens after 5, but there's a closed point. So let's put a bracket there. We should probably actually put a bracket on that 0 as well. So including 0, right? Because at 0, he's above the water. He's standing on the cliff. Okay, pops out here, he's above the water, and he's still above the water. We don't include these points because, again, at 1.5 and 2.5, he's not above or below. He's just kind of breaking the surface. Let's put a U in between them to tie them together. That's that union symbol again when we have two intervals. Okay, let's take a look at the negative now. So this is where he's below the water from about 1.5 seconds to about 2.5 seconds. We're not going to include either of those because we just talked about at those times he's not above or below. He's just at that level. Okay, so these are all intervals, right? They're sections of the domain. They're pieces of the domain. Basically what we're doing is we're dividing the domain into sections, right? So positive, negative, positive. Okay, we can also divide the domain up by increasing, decreasing. So I'm going to do that in a different color. Okay, so these are different intervals, but he's increasing in this section of the graph. He's decreasing in this section of the graph between the two pencil lines. And then he's increasing again in this section of the graph. So we're just taking little chunks of the domain and we're talking about what's happening in those chunks. Okay. The last thing we want to talk about here is maximum and minimum. Okay, so maximum and minimum are talking about y values. In this case, it asks what the maximum height was and what the minimum height was. So when we're describing a graph, if we're talking about the maximum, that's actually the maximum y value. In this case, it's 25, and the minimum is talking about the minimum y value. That's going to be -5. Okay. We also talked about x and y intercepts. So when you're looking at all these things together, we're talking about key features. What describes the graph? If you were talking about your own features, we could say that you have, brown hair or blonde hair. You have blue eyes or green eyes or brown eyes. We could talk about your height. Those are your features. Okay, the features of a graph are: when is it increasing? When is it decreasing? When is it positive? When is it negative? What is its max? What is its min? What are its x and y intercepts? So these are all features of a graph. Okay. Now there's a handout that I gave out that I want to walk through with you really quick that talks about those key features. So this was kind of a warm-up to get us going. There's also another side, so I'm not going to go through this with you. That'll take a long time. But you can go through and practice with this other scenario. This is about money, basically, in a lawn mowing business. Okay, this is the handout that you have here. It should be in Canvas for you, so you can download it and put it in your notes. But this is talking about some of the features of function graphs. Not all of them, but it talks about some of them. Okay, the first, we talk about the x and y intercept. So algebraically, if you want to find the y-intercept, set x equal to 0 and solve for y. We talked about that when we were talking about standard form a couple weeks ago. So that's important. Now, I'm not going to make you do that on your homework, but that's just a good thing to remember. To find the x-intercept, you set y equal to 0 and solve for x. Okay, and there's some examples of doing that. Okay, this is important too. X-intercepts are also sometimes known as roots or zeros. Probably won't come up a ton in this class, but it will come up in SM2, so that's good to know. Okay, now on the graph, our intercepts are the locations or points where the graph crosses the x or y axis. So if this is the x-axis and this is the y-axis, this guy right here, the graph is crossing the x-axis. So this is my x-intercept, that point. And this right here is my y-intercept. Okay, so they're coordinates. Remember that they're coordinates. All right, the next key feature of our graph here is where is the graph positive or negative? Okay, so what I would write here is above or below the water. Okay, now not every graph is going to be about water, but that's kind of a good way to think about this. Positive or negative, we're not talking about slope here. Okay, so give yourself a note. This is not slope. We're not talking about if the slope is positive or negative. We're talking about if the graph is above the x-axis or below the x-axis. Okay, and remember we're using intervals here, interval notation. So the positive region of a function are those intervals where the function is above the x-axis, above the water. Not at the water, above the water. The negative regions of our function are those intervals where the function is below the x-axis, or below the water. Right? So above or below. Okay, now this is where it gets a little bit cut off in the handout, but it says some functions are positive everywhere, some functions are negative everywhere, some functions have both. So let's jump to the next side here. Okay, so this is positive over the entire domain. This is negative over the entire domain. And this one right here it's mixed. Okay, so this is like below, this is the water level. We're below the water level for a long time, and then we cross the water level, and then we're above the water level. So we can divide this domain into two sections, right? And on this side, we're negative, and on this side, we're positive. Okay, again, we're not talking about slope. We're not talking about increasing or decreasing. We're talking about above or below the water. So in this case, the entire function is above the water. In this case, the entire function is below the water. Okay, and in this case, you have kind of half and half. All right? Okay, the next little bit here is the increasing or decreasing. So this is what direction you're going. Okay, this is more of a slope idea. All right. So in our diver scenario, this is like, is he going up or is he going down? Okay. So if you look at this graph, you can divide this domain into sections. Okay. And you have a couple sections. So he's increasing in this section, right? He's going from left to right. So he would have to go up and then straight and then up and then down. So increasing, we call this section constant, increasing again, and then decreasing. So in this section, we're always going to go from left to right, right? And a function is increasing if he's going up. Okay? Think about this as like positive slope, right? So walking up the hill, walking down the hill. Let's look at this interval for a second. This interval starts at -5 and it goes to -2. So we're not talking about the height, we're only talking about the x values. Okay, so what interval is he increasing on? He's increasing from -5 to -2. And so you can see that right here. They write it two different ways, right? So here's the interval from -5 to -2, between -5 and -2, he's increasing. And this is the interval notation. So again, this is not a coordinate. It looks like a coordinate, but we're saying this is the interval where he's increasing. Okay, he's not increasing at this point because he starts going flat, and he's not increasing here. So we don't include the endpoints. We just put parentheses around them. Okay, now there's actually another point where he's increasing. It's from here to here. Okay, this interval starts at 1 and ends at 3. So we got this interval, which goes from -5 to -2. And then we have this interval, which goes from 1 to 3. Okay, so you can see that here. He's increasing from 1 to 3, or x is between 1 and 3. Or the smallest x where he's decreasing is 1, and the biggest x where he's, increasing. He's increasing from 1 to 3. Okay, so that's what it looks like in interval notation. So we got this inequality. This is the interval in interval notation. Okay, now we can also talk about when he's constant. So this interval right here, constant, is from -2 to 1. Right, from -2 to 1. And this interval of decreasing is from 3 to 5. Right, so we're not talking about the y values. Don't worry about that. Don't worry that he's going from 4 height all the way down to -5 height. We don't care. We're not talking about where he's at height-wise. We're talking about what time, basically. So from 3 to 5. Maybe this is seconds. I don't know. 3 to 5 seconds. Okay? The rest of this is just kind of finishing up that same example, right? We have our decreasing interval. We already kind of talked where that was. From 3 to 5, or 3, 5, like this. This is interval notation. That's where he's decreasing. And then the constant interval is right here. We already kind of added those to our graph. All right, there's our constant interval from -2 to 1, and there's our decreasing interval from 3 to 5. So we got intercepts, we got increasing, decreasing, we got positive or negative. Okay, those are some of the key features of the graphs that we're going to be talking about. Another one to talk about is max and min. We'll take a look at that when we get to our homework assignment, which is coming up next. So check out the next video, and I'll help you get started on your homework.